3, that, and you pull out a finite set, you're still going to be left with an infinite set, right? If I take these out, and of course I still have an infinite set left, but I'm not saying that. Can you pull out an infinite number and still be left with an infinite set? Yeah.
The criterion is bound, so if minus infinity to plus infinity, because when they add up.
That's interesting. Okay, let's talk about that. But anyway, how about here? Can anybody think of the example? It's kind of tricky. Okay, it's an easy example once you think of it. If I start with that set and I pull out all the even numbers, right? So I'm pulling out an infinite set. What am I left with? All the odd numbers. They're still infinite, right? Okay, so that's one example, right? So infinity behaves very strangely, right? Right? Everyone follow that? Okay, now one last thing. I know we're sort of, we still have a minute. Okay, so what did I say about that bound? If you start with, I'm sorry, can anybody give me a set which when you add up all the elements, the sum, so-called sum, is bounded, or in fact equal to 1. So here's the answer. 1/2, 1/4, 1/8, 1/16. So what are those numbers? Yeah, they're fractions, but not just any fractions. They are each, this is 1/2, the next one is 1/2 squared. Next one is 1/2 cubed, right? And each time you're just multiplying the last one by a half, right? Right? So this one, to get this one, you multiply this by a half. To get the next one, you multiply this by a half, right? So if you add those up, I say you're going to get 1. So you might say, how can you prove that? And I'll prove it right here. Okay, ready? Suppose this whole length is 1. The length of the whole desk. Okay, ready? I'm going to step up. Right? Okay. Now I'm going to go half of that. I'm going to go here, right? Then I'm going to add half of that. I'm going to go here, right? Then I'm going to go half of that. Am I ever going to go past here? No. So it's bounded by 1. Right? So if you take this infinite sequence of numbers, right? And you add them up, it's never going to be bigger than 1, right? Okay. So anyway, the point is that has slightly something to do with the idea of limits. And limits have to do with sort of trying to work with infinity. Okay? And we need to work with infinity because we are trying to get slopes of basically points that are infinitely close together. If I want to know the slope at a tangent, at the tangent line, basically I have to talk about 2 points on the line, but bring them infinitely close together to get the tangent line. Okay, so we have to deal with this idea of infinity, and limits help us to deal with that. Okay, so you just got 2 very bizarre aspects of infinity, right? Infinity is not, we don't have a good intuition about infinity, right? And that's probably because, at least, we don't think about it. And we also don't sort of deal with it. I don't think our brains have that kind of training, or even that kind of aptitude. Okay, all right, enough of that. Okay, so we'll make sure you get the homework done.